Good morning, children. Today we are starting chapter 3 of class 11th, and there some concepts need your attention, and then after we'll move on to the main topics. So first we need to know what is in which branch of physics do we study motion. We have two branches of physics where we study motion. We are talking about dynamics. It is the branch of physics which deals with the motion considering the cause of motion. And in case of kinematics, this is a branch of physics where we consider the cause of motion also while studying motion. Then we have three ways of studying motion. If the motion is along a straight line, then we have motion in one dimension. If the motion is explained using two coordinates, then the motion is called as two-dimensional motion, which is also called as motion in a plane. Here you can take the example, when you move out of your house to reach your school, you take different roads, but all those roads are on the same plane. So that's why that motion can be considered as motion in two dimensions. Third is motion in three dimensions. For example, a kite flying in a sky may fly right, left, forward, backward, or up, down. So this way, this can be considered a three-dimensional motion. Similarly, a bird flying in air. Right? Now, we come to the concept of frame of reference, which you have studied in 9th standard. Because we know that a body is said to be in motion when it covers some distance with respect to some reference point with time. So, like if we have a point O, right, and an observer standing here and a car which is moving on this road, right? So with respect to this, if we consider this as reference point, then with respect to this point, the car has covered some distance, is covering some distance. So this is said to be in motion with respect to point O. That means with respect to the observer at point O, right? But for an observer who is sitting inside the car, right? So if this is observer A, then and this is observer B, then for the observer who is sitting inside the car is at rest with respect to observer inside it. Right? So we have two different frames of reference. Here this is the reference point. So this is one frame of reference where the observer is at this point of reference, and this is another frame of reference where the observer is well inside the car and he himself is moving along with the car. So in both the cases, we know that we have a reference point, we have a clock to measure the change in position with respect to time, and this way we will be able to know that in what reference point the object is moving. Now let's come to the concepts of position, path length and displacement. We have studied in class 9 that whenever we draw a number line, there is a figure given in your NCERT. I will try to draw that figure on the board. So I am drawing that figure to explain these concepts. If this is our number line, where I will mark some points. If this is the origin, I'll take the difference of 40 as given in your NCERT. So here. So here, if I'm taking 40 difference, this is 40, 80, this side is plus side, this is 120, this is 160, this is 200, this is 240, this is 280, this is 320, this is 360, this is 400, this is 440, and so on. And on this side we have minus 40, minus 80, minus 120, minus 160, then we have minus 200, and so on, right? So this way, this is the number line, and we are considering this as the reference point, right? So if we are talking about the position, so position, that means with respect to point O, which we are considering the origin. So this is the motion along x-axis. So here we are discussing this motion with respect to the origin, and the motion is along the x direction. Here we have different positions. Positions of a car at different instants, right? So we have different points here. R is at 120, so this point is R, because we have discussed these reference points for this. So this point is O, we know this. And then we have Q at 240, so this is Q point. And then we have P at 360, so this point is P. Now for discussing this concept, we need to understand that what we are considering here, we are considering here the rectilinear motion. This rectilinear motion is also called as motion in a straight line, right? Now for this, we know that O is the origin. So if O is the origin, and we have to consider different cases. Suppose we are considering the case from O to P. So we are considering this case from O to P. And then second case, O to P, and then P to Q. Third case, we will consider O to P, and then P to O, right? So in all these cases, we will understand the concept of position, path length, and displacement. Position means whatever point the car is with respect to the origin. Now path length. So path length for OP. Just check, what is this? OP is this part. So path length for OP is how much? Plus 360 meters, right? And when we are talking about displacement, how do we find the displacement? We have studied this in 9th standard. So this gives us final position minus initial position. So this way, you know that if we have to find the displacement from O to P, so you can say that the position at P minus position at O, and this gives us 360 minus 0, and this gives us plus 360 meters, right? Now, this path length, this path length is actually called as distance. So in this case, distance and displacement are equal. Let's consider case 2, when the body first moves from O to P and then moves from P to O. So this is the case. If we want to write the path length here, how will I write the path length? So path length will be actually OP plus PQ. So OP is how much? Plus 360 plus PQ is how much? This is 120. So this is 120. This makes it 480 meters. Similarly here, you can write down displacement. And for displacement, we want the final position minus initial position. What is the final position? So X, Q is the final position. Right? Minus what is the initial position? Initial position is O. So final position is plus 240. Right? Minus initial position is 0. So in this case, what is the displacement? The displacement is 240 meters. So here path length is greater than displacement. Now let's consider another case. The body moves from O to P and then again moves back and reaches point O. Then what will happen here? The path length will be this actual plus this actual. That means plus 360 meters plus 360. That makes it 720 meters. Right? Now if we want to write the displacement, we know that the final position is O and initial position is also O. So that makes it 0. Right? We can take another case. We can take another case to understand that displacement may be negative also. So here we are taking O to Q and then Q to R. Right? In this case, path length is equal to OQ plus this plus this length. So this length will how much? Will be how much? OQ plus P. We are talking about O to Q and R now. So this is OQ and QR. So OQ is how much? This is 240 and plus how much is the path length of QR? So how much is the path length? This is 240. 240 plus 120, that is 360. So this makes it 600 meters. But if we talk about the displacement, displacement means final position is what? R minus initial position, that is O. So this makes it R is minus 120 minus displacement X naught is 0. So this makes it minus 120 meter. So this way we know that the displacement may be negative also. So this makes the concept clear that how this position, path length and displacement are related to each other. That's all for now. Thank you.